Hi, I hope I'm audible and visible to all of you. Could you give me a quick yes if you can hear and see me clearly? That's awesome. So what we're going to study today is how to set up a permissioned blockchain using the multi-chain framework. So let me give you a quick introduction. So when we usually look at blockchains like Ethereum and Bitcoin, they are what we call permissionless, which basically means you don't need to take permission from anyone to run nodes or to access the chain or to do various transactions. However, when we look at enterprise use cases, most of the time they're going to be looking at permission blockchains because we're talking about real world high value transactions. Plus, we're looking at things like KYC, know your customer, and other kinds of laws being followed. So you need to know who's connecting to the chain, and then depending upon that, you can give different permissions. Now, for this, we are going to use something called the multi-chain framework, which is a fork of the Bitcoin core. So as we know, Bitcoin core is what runs Bitcoin, and that is by far the world's most tested and secure blockchain framework. So multi-chain has forked that and then made an API layer on top of it, so that instead of running just one asset, which is native to Bitcoin, we can create multiple assets. And then we can enable transactions between different addresses. We can give them different permissions. We can even set up things like data streams wherein we can store a lot of information. So the first step is obviously we need to create a server. And on that server, we are going to set up the blockchain. So in this example today, what I'm going to do is I'm going to show you how to set up an Ubuntu Linux server using a cloud service called DigitalOcean. Now, you could use anything else. You could use your laptop, or you could simply use any cloud service that you want. So, like Google, Azure, IBM, you can use AWS, you can use any of them. I'm just going to be using DigitalOcean. So, let me quickly share my screen with you guys. I hope this is visible to you. So, you should see something called create droplets. So, can you just give me a yes if you can see create droplets written and then a bunch of flags below that? Just give me a quick yes and then I'll start off. Uh, awesome. You can see it. So let me start. And don't worry, I'll take your questions a little later. So the first thing that we are going to do is we are going to create a droplet. So different cloud service providers give different names, but ultimately it's just a virtual machine. They just call it a droplet, right? So the first thing we need to do is we need to choose the region. So ideally here you should be choosing a region which is, or this is a data center where they're actually running the computers. It should be as close to you or to your users. So if you're in India, you could choose Bangalore. If you're in the US, you could choose New York or San Francisco. So you take a call, whichever one is closest to you or closest to your users, or then anyway in a blockchain, we are going to have multiple nodes. So maybe some are closer to where you are running it from, some are closer to your user. So I'll just leave it here as default as Frankfurt. Then we get to choose which operating system we want. So there's an option between, so this is just for Linux. So we have Ubuntu, Fedora, Debian, CentOS, and Rocky and Alma. I prefer to use Ubuntu. And then you have a drop down where you can choose the different versions. Again, I'm just leaving the default here. Now, depending upon the chain you're setting up, you may need to change the servers. But here for multi-chain, almost all the OSs work. Again, here for the shared CPU, I'm just going with basic. I'm going with a very cheap server. This is just an experiment. Later, when you're going for production, obviously you would set better parameters. So I'm choosing a regular SSD hard disk, and I'm choosing the absolute lowest, which is $4 a month. So as you know, cloud services are not very expensive. So I'm taking a very basic $4 a month server. So I want you guys to understand that blockchains need not be very resource intensive, right? Now, after all this, we are going with the password based system. So we can either go with an SSH key or we can go with a password. Now, if you're comfortable with using SSH keys, that's fine. First time ever, so I'll just take a password. So this is going to be the password of our servers. Now we can decide to set up servers also. So if I say two servers, then I can give them different names. Now in a blockchain, the first node which we set up, let's call it the seed node. And the second one that we are going to set up, we will just call it the node. So seed is going to be our first, or let's just call it second node, right? So seed node and the second node. We can give tags here if you want. The project is just internally that all the servers that I'm creating here, which project do they belong to? Doesn't matter. So now we are going to create these two droplets which have the same password here. We are using password instead of SSH key, and it's a $4 a month server with a regular SSD hard disk. So after having filled all this, all I need to do is create droplet. So as we can see, it doesn't take much time for it to be set up. Once it's set up, what it's going to do is it is going to show us the IP addresses of both these servers. And then we will start with the first one. That's going to be our seed server. We will set up the blockchain there. Then we will set up the blockchain on the second server. And then we will connect the two. Fairly simple. In the meanwhile, let me just see if there are any questions while we're waiting for this to happen. Okay, no questions so far. Uh, Preeti's asked about what about hash? I'm not sure what your question is. Can you explain it more? So now here we can see that there are two IP addresses available. So for this seed, we see the IP address 164.90.183.149. So I can just hover over this and copy it. Now what I'm going to do is I'm going to open up terminal. Right? Let me just show it to you guys. Give me a second. I'm going to change my screen. So now all of you should be able to see this blue command line here. Give me a quick yes when you guys can see it. So the first step that we are going to do is we are going to log into this server, right? So here's the command that I'm going to run. So the first command is ssh root at 164.90.183.149. So I'm logging in as a root user, and that is the IP address of the virtual server that we have just created. I hope all of that is pretty simple. And then I press enter. Now the first thing that is going to do is it is asking us, so it is showing us a key fingerprint and asking us, are you sure you want to continue connecting? So I just say yes. Right now the next step is I need to enter the password. So let me just quickly enter that. Okay, so now once we've entered the password, we've logged into our Ubuntu Linux server, and we are in this server which is called seed. That's the name given by us. And now we are going to set up the blockchain. So first step, now here if you are comfortable with Linux, then that's fine. You would understand everything that I'm saying. If you're not comfortable as of right now, it doesn't matter. You can just follow these commands. Later I'll share the links with you where all the commands are there. So cd, we're just changing our directory to temp. Then we are going to run something called wget, which is going to get the zipped file or the archived file. So after all, Multichain is a software. It's located somewhere in the world. That particular URL, which you can see here, the download URL, we are getting the file from. Once we have that, we will unzip it. So I'm going to run the next command. I hope all of this is clearly visible to all of you. Okay. So once we've unzipped it, we are going to change directory. Again, these are very standard commands available from the website of Multichain. So don't worry if you don't really know what they mean. You can just run them, right? Now we are going to create the blockchain. So what we did right now was we downloaded the relevant software, we extracted it, we moved it. Now we are going to run a very important command. So you can see it is multichain hyphen util create. So we are going to create a new chain and I'm just calling it Rojas, right? You can name your chain whatever you want. So we enter. So now it says that the blockchain parameter set was successfully generated. You can edit it before running multi-chain D for the first time. So you can make certain changes to the chain you are about to create. As of right now, it's being our first time, so we are not doing anything like that. We are simply going to run this command that they are telling us to run. So this command is multi-chain D space the name of the chain, which is Rojas, space hyphen daemon. I press enter. So now a lot of very interesting things have happened. So starting up the node, it is looking for the Genesis block. As you know, that is the first block created for any new blockchain, also called as block zero. It has found the Genesis block. Now other nodes can connect to this using this particular command. So we can copy it and keep it. And when we set up the second one, we are going to use this. So what it means is the main seed node is now up. So technically your blockchain is up and running. Anybody else who wants to connect, because they need your permission also, they will need to run this on their own computer and then we will be able to allow them to connect, right? So it says node ready. If you guys have questions, you can keep putting them. I'll answer all of them in some time. Now that we've done this, there's just one last command that I'm going to run, which is multichain hyphen CLI command line interface. So it makes it easy. So we have moved into something called the interactive mode. So it makes it easy for us to now interact with our node. So the first command we can now try out is something called get info. Now what this is showing us is all the information about the blockchain. So a lot of this is very common to what shows up when you run a Bitcoin node also. It's just that multichain has added a few more things to it. So for example, when you look at the protocol here, so multichain actually supports the Bitcoin protocol also, as well as the multichain protocol. So here it is showing us that the chain that we've set up is the multichain protocol. And there's a lot of information here. One of the most important that I'd like to talk to you briefly about is called the burn address. Now, some of you may be wondering what burn address really means. So, if you've heard that in the Binance Smart Chain, from time to time, they burn certain BNB coins. So, what they said was during their initial ICO, we will start with 200 million BNB and then every few months we will burn some till we are left with 100. So, burning is a very common concept in blockchain. In a blockchain, we cannot delete anything. So suppose we want to get rid or we want to remove certain tokens. What do? Anything sent to the burn address is lost forever. So a burn address does not have any known private key, which means anything sent to the burn address can never be recovered again. So you have to be very careful when you are sending something to the burn address because once you send it, it's gone. And then we can also try another command, which is called the get blockchain parameters, right? So we can have a look at that. And then again, we see a whole bunch of parameters here. So now this being just the setup stage, I'm not going into each and every one of them. Later, I'm going to share the details with you where you can read what each and every line here actually means. Now, for many of you, this may seem like very overwhelming. Like, why do we need to read all these lines? And that's where a blockchain engineer comes in. See, you're not a blockchain developer. A blockchain developer wouldn't care about all this. They would care about creating the dApps which connect to the chain. They would care about the APIs. You, on the other hand, as a blockchain engineer, have to set up the chain. So for you, it is very important to understand what each of these means. And also remember, you can change some of these. So in a blockchain, there is something called as runtime parameters. Those can be changed even once the chain runs. However, there are some basic parameters that cannot be changed once the chain runs. So those you have to do beforehand and some you can do later. So that is why it is very important for us to understand all of these. So depending upon the use case for which we are creating a chain, we would need to modify different parameters. Another thing I want you to remember is sometimes in organizations you actually will have multiple chains running. So depending upon different use cases, you may actually be running 10 and 20 chains also. So for each chain, we have to be very, very careful. What are the different permissions that we need to set up? If there are any questions, keep putting it there in the comments. I'll take them. Now what I'm going to do is I'm going to set up the second node. So let me change the screen. Give me a second. So now here we can see that we took the seed node first. Now we can see the second node. That is the reason we have given names to each so that we don't get confused which one is doing what. So here when we go over the second node and we see the word copy written, we just click on it. So we have now copied the IP address and we are going to log into it. So now I'm going to go back to the command line interface and open up a new one. Let me share it with you. So the seed node, you can just remember, is the blue screen and the second one is the green screen. So it just makes it easy so we don't get confused. First step again, we do SSH root at 165.232.120.199. So this is the second one. If you remember, in case of the first one, the IP address was different and it was 164 dot something something. This is 165. So here again, we say yes. Let me enter the password. Okay. So now we are in this server and now the first few steps are going to be identical because we are basically just downloading the software. So we're changing the directory. We run our wget, then we run give me a second, let it finish downloading. Let's change directory. Let's run the move command. Okay. So now if you remember, when we were setting up the initial blockchain, when we set it up, it said that other nodes can connect using a particular IP address and port. So now, since we had copied that, we have put it here. So we are now connecting to the seed. So we're using the IP of the seed, the 164, and we also have the port number here. So here what it's done now, this is very important for us to understand what's really happening. So first step, it retrieved the blockchain parameters from the seed node 164.90 and the blockchain was successfully initialized. Now what it's saying is, please ask the blockchain admin to let you connect and or transact. Now this is not something that would happen in a permissionless chain. This would happen only in a permission chain because you cannot connect without the admin allowing you to. So here it has given us examples. Suppose we only want connection permission, which means our node is simply connecting there and nothing else is happening. Then the admin will run this multichain -cli, the name of the chain, and then it will grant. And this is the address of this particular node. So as you know, on the blockchain, everything has an address, right? Whether it is an individual user, an entity, or the node itself, all of them have addresses. So this particular node we've set up has this address. Of course, you can generate as many addresses as you want. Now, after that, we can say connect, or we can say connect, send, receive. So later we are going to learn that in multi-chain there are various kinds of permissions. So we're going to understand what each permission means. But to put it very simply, connect allows you to connect to the chain. So obviously that's critical. Send allows you to send assets, receive allows you to receive assets. So we would send this entire line by email or by some method to the admin and the admin would need to run this on their interface. So let me just copy this. Now I have to go back to the main server, the blue one if you remember. So let me find that. Let me change my screen. So when I go back here, I can run this command. So another thing to remember is that on the blockchain, every time we do anything successfully, it is going to generate some kind of a hash for us or a result, a transaction ID, and everything is getting logged. So when we granted permission to this address for connect, send, and receive, it ran that command successfully, and because it was done successfully, it has generated this transaction ID for us. Now, depending upon situations, we may choose to save some of these to our database, or we can ignore them. It doesn't matter. Now, how do we check whether everything is running fine and whether this particular node that we are talking about has actually been connected properly? So one simple way is we can simply run list permissions. Now here we can see that our original permissions, right? For the first node, by default, it gets everything. This is the address of that. It has by default connection, send, receive, mining, admin, activation. All these permissions are available to it. And of course, the connect, send, all of these receive permissions are here. Now, for the other one, for the new one that we've set up, we have limited permissions only, and those are also shown here. So there we have given, okay, sorry, my bad. These are the of the secondary node that we set up. The first three relate to that one, which is connect, send, and receive. And all the others that you see here relate to the main address of the main node, the seed node that we have set up. So here we can immediately see now that these two nodes are connected and communicating with each other. Now, I know some of you may find this a little complicated, so let me see if you have any questions. Seema wanted to know, how do you find the IP of this thing? So the IP address, like I said, is generated by DigitalOcean itself. So let me just show you what that looks like. Give me a second. So here, every single node that or server that we create, the IP address shows here. So we don't have to do anything in that. That is done automatically for us. Any other questions? Can you just give me clear if everything that I've said so far is very clear to all of you? And like I said, don't worry if this seems complicated. Once you do this on your own, things will become a lot easier. Let's see if you have any questions. Give me an all clear if it's clear to all of you. Okay, very clear. That's amazing. Let me just show you one last command before we move on. So I can also run various kinds of commands, which I am going to show you now on the multi-chain site. This is something that you all are also going to practice. So all these commands, right, which multi-chain supports, these are called JSON RPC, remote procedure calls, that we are going to use. And they're very easy to integrate into software. So your developer's job becomes very easy. So as you saw that we saw something called get blockchain parameters. So it explains to us, then we can do runtime parameters. We can even set these runtime parameters. So I told you there are certain parameters we can change. Then we can do get info. So for each of these, it is going to tell us what it means. In fact, if we want to shut down a node, we can use stop. If we want to see a list of available APIs, we can run the help. So all of this is available to us. Then we can create addresses. So, something like get new address, a very simple command to run. Let me just show that to you. Give me 1 second. I forgot to show my screen. Yeah. So as you can see, when I run get new address, it immediately shows me. So it gives me this address here. It also, now the second time I run the command, it again gave me another address. And if I want to see what are the permissions, right? So this one, if you look at all the permissions here, you will realize that this new one that we have created, this 1s doesn't even show up anywhere because we've not really given it any permissions. By default, when you create an address here, there is no permission given to it. You have to now give the permissions. So let's say we are talking about a real life scenario, and let's say a bank is onboarding its customers. So the bank could, by default, the moment a customer's KYC is done, create an address. Then, depending upon the level of access it wants to give, it would choose what permissions to give. So in many cases, they may not give connect permissions because the bank will have a node on which it is onboarding all its customers. So the customers per se do not need to go and connect to other nodes on their own. They are simply going to use the mobile application of the bank to interact with the blockchain. So it's very important for us to understand that blockchain need not be introduced to the end user. Like today, when you log into a Paytm or a WhatsApp or anything, or even a bank app, you don't know what tech platform they're running on, and you don't care. You just want to do your transaction. Same is the logic here. A bank could onboard you onto their node, and you wouldn't even realize. You wouldn't even see the address. That is something the bank knows in its database, right? So that was the basics. Now let me take some questions. So to give you a quick overview, we first set up two virtual servers using DigitalOcean. You could use any cloud server, you could use physical servers, you could use your laptop also. Then we set up multi-chain as a blockchain on one of them. Then we set up a second node which connected to it. And then we saw how we can create addresses, and we kind of got an overview of what kind of permissions we can give, but of course we will go deeper into the permissions. Now let me just take some questions. So the first question that I can see here is, transactions will take place on these individual nodes, and in turn individual chain of blocks will get created for the same. Yes. So what really happens now, if you've gone through as the homework, I told you to go through that video on the Bitcoin white paper. So if you recall how it ran in the Bitcoin white paper, there we use something called proof of work. Now, in that, these various transactions that are happening over a 10-minute period, they go into the memory pool, and then a whole bunch of miners is going to work on it. And the first one to calculate the proof of work, that nonce, will broadcast it, and then that block gets propagated to all the nodes. However, here, even though multi-chain runs on Bitcoin, there are some changes. So, for example, we are not using the regular proof of work because that is not necessary or useful for a permission chain, because we know exactly who's running the node. There is no competition between them. So, in this situation, if there are 10 nodes, the first block is mined by the first node, the second by the second, third, that's how it goes. If one node is down, the next one gets it. So it uses something like what we call as a round robin proof of work. So it actually saves a lot of energy. And so the node which mines a particular block can then propagate that information to all the others. So it's a little different compared to the way it would happen in Bitcoin. Any other questions? So what I'm going to do now is, of course, this video will be available to all of you to watch, and then I'm going to give you your homework, and please make sure you do it because otherwise you won't be able to move forward. Let me look another one. The permissions of the multi-chain node reminds me of I am in AWS. Okay, I haven't used AWS, Srishant, so I wouldn't be able to comment on that. But if some of you guys have used it, you'll probably understand what Srishant is saying here. Are there any other questions that you guys have? So today was the first one, so I don't want to overload you. The homework is going to be, you are going to set up your own blockchain, and during another session, we are going to, connect. So all of you are going to run a node which is going to connect to the seed. Don't worry, we'll do that in some time. Let me take another question here. What is issue permission? So that is for issuing assets. So that is something we are going to go into detail later. That asset could be anything, right? It could be a token which is like a utility token, a subscription token. It could be a real world asset backed token. So any of those are called as assets. And as I always keep saying that the most important use case, I mean, what blockchains are built for is something called smart asset lifecycle management, where you're creating assets, sending them around, escrowing them, burning them, all those different things that you can do. So we'll go into these permissions in great detail. Dave wants to know when I will take the blockchain quiz. Sure. You mean the live one? Yeah, sure. I'll plan it very soon. Don't worry about that. So as of right now, I hope you guys are taking the quizzes. I keep posting them on the LinkedIn group as well as on the WhatsApp group that all of you should logically be a part of. So there I'm putting daily questions. But from time to time, I also have live quizzes, and sometimes there's a prize also. And yeah, I'll do that very soon. Let's look at the next one. What are the real use cases in real life of multi-chain? Sure. So let me be very honest with you. Almost every blockchain use case that we talk about is going to run on a permission blockchain. See, other than cryptocurrencies, for that we use the public permissionless. But other than that, whether we talk about things like supply chain, we talk about real world asset backed tokens, because again, we need to follow all the laws. So let me give you a very simple logic here. That why is it that we use permission blockchains for all the enterprise use cases? You could use Hyperledger Fabric, you could use Corda, which is a blockchain in software. Hyperledger is a distributed ledger technology, or you could use multi-chain. Wherever, in whichever use case, we need regulatory compliance like KYC, AML, CFT, data privacy, right to be forgotten legislations, freezing of assets, then we have to use permission blockchains. So when we want to do supply chain, we would use something like this. When we want to do tokenization of real world assets, we would use one of these. So most of the use cases that you hear about, you are going to use this. The only place where you will not use multi-chain is when you are doing a DeFi case, decentralized finance, because that is ideal for platforms like Ethereum, Polygon, and so many others. Other than DeFi, all other kind of enterprise or government use cases that you talk about, you are going to end up using a permission chain like multi-chain. Hope that answers your question. Uh, Somebody wants the link for the WhatsApp group. Sure. Let me give you the link. Give me a second. Uh, yeah. Okay. I have put the link for the WhatsApp group number 3. Right. So since 1 and 2 are full, you can use 3. Okay. Any other questions? So I put the link, you can take it. And now I'll send you guys this link for this video also. Watch it again and then follow the practical, set up your own chain. And please make sure you do that today so that tomorrow I can take you to the next level. So for tomorrow's session, all of you who have set up your own chains are going to send me that one liner in the chat. And then in real time, I'm going to connect all of you and I'm going to give you permissions so that then on your chains, you on your nodes, you can try out some of those APIs. So great. I hope you guys learned something useful today. I'll see you guys tomorrow. Bye bye.